Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 23 in the cross-site scripting module titled Stored XSS into onclick event with angle brackets and double quotes, HTML encoded in single quotes and \escape. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, do a search on cross-site scripting labs, and go down to lab number 23, titled Stored XSS into onclick event with angle brackets and double quotes, HTML encoded, and single quotes and \escaped. All right, let's get started. This lab contains a stored cross-site scripting vulnerability in the comment functionality. To solve the lab, submit a comment that calls the alert function when the comment author name is clicked. So our target goal over here is to perform an XSS attack that calls the alert function when the comment author name is clicked. So let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. All right, as usual, when you're looking for cross-site scripting vulnerabilities, you're looking for client-supplied input that gets reflected back in the application. So if we go down right over here and click on View Posts for one of the posts, you could see that there is a comment functionality and you're allowed to leave comments. So any comments that you enter over here will get displayed back to you in the application. And so any fields that get displayed should be tested for cross-site scripting vulnerabilities. The first thing we're going to do is put in dummy data and see which fields are displayed to us. So for email, let's say test@test.ca, and for website, let's say http www.test.ca, and post a comment. Let's go back to the blog. And when we do that, let's actually just send our post request to repeater just in case. And if we go down right over here, you could see this is our comment. So the comment field is reflected back to us. The name field is reflected back to us. And if you hover over the name field, the website field is also reflected back to us. So all three should be tested for cross-site scripting vulnerabilities. I'm just going to right-click and inspect and do that again so that it works. And I accidentally clicked on it, so it's trying to visit test.ca, which doesn't really exist. So let's go back to the blog, go down, and then right click and inspect. And here we go. So you could see right over here, we've got the name of the author in the A element. We also have the website in an href attribute and in an onclick attribute. So it gets placed in two locations. Now, based on the exercise description, it says perform an XSS attack that calls the alert function when the comment author name is clicked. And so we need to exploit the XSS vulnerability within the onclick function. So our exploit should be in here so that when a user clicks on the user's name, the XSS vulnerability gets run. So let's right click and view page source and look for test at test.ca. This is the string that we want to exploit. So let's copy it, put it in here. And we're specifically looking for onclick. So let's remove all of this because I don't really care about it. All right, so we need to somehow inject our cross-site scripting vulnerability in this function right over here for the user to be able to click on a name and then for this cross-site scripting vulnerability to execute. So what I'm going to do over here is go back to the application and just see if the application accepts any random website. So let's say test, and then test.test.ca. And then for the website, let's say http www.test.ca, and then let's say script, hit enter. And it looks like it accepted it, which is a little bit shocking. So if we go back over here, and we hover over this, you could see, oh, URL encoded it, and that's why. So let's build our payload first and see if the application will accept it, and if it's not, we'll have to just alter our payload to one that is accepted by the application. So the first thing that we need to do is close off this string right over here. And so I'm going to add a single quote, and then I'm going to add my alert function. So we'll use the minus sign, alert, 1, and then minus sign again. And then we need to close off this single quote. So we'll add another single quote right over here. So let's copy this and see how the application interacts with it. So let's say test, and then test at test.ca. And then for this one over here, we add our payload, post comment, go back to the blog, go down, and let's inspect this, go down, and it looks like the single quote is escaped. So that's going to be problematic. The next thing I'm going to do is try and see if the HTML entity version of a single quote is escaped. So that would be and a pause and then semicolon. So let's replace our single quotes with that. So that would be one, and this would be another one. Let's copy this entire thing and add another comment. And then let's say test up. Oh, this would be our field for the exploit, post comment. And here we go. It says, congratulations, you solved the lab. Let's go back to the blog over here. Go down and just click on it to see if we're alerted, and we are alerted. Let's click OK. And then we get an invalid client request because we're trying to access a URL that does not actually exist and is not really invalid. All right, so the payload that worked for us over here was this one over here. I'll leave the link to the notes.txt document in the description. Okay, so we successfully completed the exercise by exploiting the stored XSS vulnerability. In the next lab, we'll look at another case of a cross-site scripting vulnerability.